Welcome to this lecture. In this lecture, we'll be using the idea of generators. Okay, let's start this class. Suppose V is any vector space over R and W1 and W2 are any two subspace of V. Then we define this set W1 plus W2 in that manner. That means my set W1 plus W2 is defined as X bar plus Y bar, where X bar is in any element of W1 and Y bar is in any element of W2. Okay. Now the interesting fact about this set is this set W1 plus W2 is generated by W1 union W2. Now what is the meaning of generator? That means they are asking us to prove that my W1 plus W2 is the smallest subspace containing W1 union W2. In different reference book, you can find the same question in a different manner, as they might say W1 plus W2 is the smallest subspace containing W1 and W2. On the place of union, they can use the word and. Since if it is containing union, it will contain both of them. Okay. So for this lecture, our claim is to prove that. That means I want to prove my W1 union W2 is the smallest subspace containing W1 union W2. That means W1 plus W2. Okay. I want to prove that. So we divide our claim into three factors. First of all, we will prove that my W1 plus W2 is a subspace of V. Correct? First of all, we will prove that it is a subspace. I know that my 0 bar from W1 plus the 0 bar from W2 will be an element of W1 plus W2. Hence, I know the given set is non-empty. Also, if I add the elements from V, I cannot go outside of the V. That means I know that that is subset of V. We have a non-empty subset. Now what we'll do, we'll consider any alpha from R and we'll consider two elements. The two elements are X bar plus Y bar, comma P bar plus Q bar. That means my X bar and P bar are element of W1, Y bar and Q bar are element of W2. Okay. Now what we consider? We consider alpha times the first element plus beta times the first element. Now we know we are working under the vector space. So we have all those 10 properties. That means we know distribution, by using which we can get the second step, right? Also we know that my addition is associated. That means wherever I want, I can write the bracket, which we have used in the second step itself, right? Then we have used the commutativity to switch that alpha Y bar plus P bar. We just switch it. Then we write bracket wherever we want. So we got the two brackets in third equality, that is alpha X bar plus P bar and alpha Y bar plus Q bar, right? Now this first bracket, is it an element of W1? Is it an element of W1? The answer is yes. Because we know that X bar and P bar are element of W1 and it is a subspace, hence alpha X bar plus P bar is an element of W1. Similarly, the second bracket is element of W2. Hence we can conclude alpha times first term plus the second term is an element of W1 plus W2. Hence that given W1 plus W2 is a subspace. So we are done with the first claim. Correct? Let's see the second claim. In the second claim, we will be proving that my W1 union W2 is subspace, that is subset of W1 plus W2. We want to prove it the smallest subspace containing W1 union W2, right? So in this case, in this claim, we are proving it is containing that W1 union W2. Correct? How we will prove that one set is subset? We will take any element from W1 union W2 and prove it is there in that the other set. Correct? Suppose I consider any element W bar from the union. An element is there in the union if it is on either of them. Suppose my W bar is an element of W1. Then I want to prove this W1 is an element of W1 plus this element from W1 is an element of W1 plus W2. Correct? I want to prove this W bar is an element of W1 plus W2. But the elements of W1 plus W2 are of the form X bar plus Y bar, where X bar is from W1 and Y bar is from W2. That means my this W1 should be written in that form. So we write it. What we write? We write W bar is same as W bar plus 0 bar, where this W bar is an element of W1 and 0 bar is an element of W2. 0 bar is an element of W2. Since it is a subspace, it contains 0. Correct? So similarly, you can prove for the other case. Right? So we know that any element from the union will be there inside the addition W1 plus W2. Right? So we are done with the second part. Till now we know that it is a subspace containing. Now come the main part. The main part means we want to prove this is the smallest subspace containing. Whenever I want to prove something is smallest, what we will prove? We will consider any other subspace which is containing it, and I will prove that my W1 plus W2 is contained inside that. That means my W1 plus W2 becomes automatically the smallest one. Correct? Okay. So what we consider K be any subspace which is containing W1 union W2. So our K has two properties. It is a subspace and it is containing W1 union W2. From this property, we want to prove that my W1 plus W2 is contained inside that K, because I want to prove that is smallest. Right? So again, we want to prove one is subset of the other. We consider any element x bar plus y bar from that W1 plus W2. That means what? My x bar is an element of W1, my y bar is an element of W2. That means I can say my x bar comma y bar is an element of the union. Right? And we know that K is containing that union. That means that is subset of K. Hence we know that my x bar and y bar are elements of K, and K is a subspace. From the first property, it is closed under addition. That means we know that x bar plus y bar becomes an element of K. We started with any arbitrary point or vector from W1 plus W2, and at the end we are proving that vector is there inside K. Means we prove that my W1 plus W2 is contained inside K. Means my W1 plus W2 is the smallest subspace which is containing W1 union W2. Hence I can conclude my W1 plus W2 is generated by W1 union W2. Okay. So this is about a simple application of the generator or the idea of it. You might find in some reference. Thank you so much for watching this video. Like, share and subscribe to my channel. Thank you.